Okay, so the first blank, 3 squared obviously is 9, so that's going to be a 9 there. All right, second blank. I have a different blank over there. X and then blank something squared. Krista? -4. How did you get that? Okay, so the -4 is half of the -8. And over here, the 9 is going to be 3 squared. So just a relationships there as we remember completing the square and where those numbers come from. All right, so we've got our steps here. And for completing the square, in general, we're going to be targeting a problem that is in this form. Ax squared plus bx plus c. Remember yesterday we dealt with ax squared plus c, and when there's no bx, and that's where, Jonah, we had that, take the square of both sides that we have on the board. Okay, that's that method. Here, when we have the whole equation, completing the square. And I've kind of got our steps in here. Once again, if there's an a coefficient, we divide both sides by a. All right, we try to get the x squared positive and move the constant over to the other side if necessary. We take half the b coefficient, square it, and then add it to both sides. All right, and the result of that is called a perfect square trinomial. And then we're going to take the square to both sides. And remember, when you take the 2 square roots, don't forget your plus or minus. And then we're going to have 2 answers in general for our problem. So let's take a look at here. I kind of walked through it. Now, what you notice on this problem down here, on this example, is there is no y. There's no y at all. And so it's very similar to what we did before, except there's no y in the problem. So our first step, and I kind of walked it through. We move the x's to the one side where they're positive. We move the numbers to the other side. And so that is our first step. Second, we put in our blanks. Plus blank, plus blank. Half of 6 is 3. 3 squared is 9. And so I added a 9 to both sides. Next, I rewrote it as a binomial square. Then I took the square to both sides, and notice on this square to both sides, notice this plus or minus right here. Because 2 square roots, remember, is 2 answers, and that's what we did yesterday's lesson first, is it leads right into today. The square root of something squared on the left is what's inside, and what was inside was the x minus 3. Then we broke it up into 2 little equations, we solved each one, and we wrote as a solution set. So, a lot of that is familiar, yes? The only thing that's different today is there's no y, and we're moving the x squareds over to keep them positive to make life easier on us. So let's look at a couple examples of different possibilities. But first, let's kick off with this. Raise your hand if you know the first blank. Curious how many know it. About a third of us. Paul?
Should be 5. No.
It would be x plus 5 down here, but what's the blank?
It would be 25.
Good. Second blank over here. Somebody else. Zach? 36. So down here it's going to be x minus 6 squared, right? Third blank. Trevor? 1. And down here it'll be what squared? X plus 1. Right, because it's half of the 2. Let's go down to the bottom row. Each of these are odd numbers. So the top row, we said half of 10 is 5, right? And 5 squared is 25. Well, down here, I don't want you to think of decimals, but what I want you to think is, what's half of -5? Would you agree it's -5 halves? Now, think with me. What is -5 halves squared? Square the top, square the bottom. 25 fourths. Nothing fancy. We're not doing decimals because decimals is going to get us really confused. We're just going to stick in fractions. I got 3 examples like this. Let's go over here.
But is it wrong to do decimals, or is it just awkward?
It'll be difficult, not awkward, difficult. It will cause you massive problems later in the problem.
Okay.
All right. So, what's half of 11? 11 halves. What's 11 halves squared? 121 over 4. You see the pattern? Let's scroll over. Half of what? 1 is 1 half. And 1 half squared is 1/4.
One squared is
1. And 2 squared is 4. So, whether it's an odd number or an even number, we're taking half the middle term and squaring it. Are we okay there? In Algebra 1, I avoided odd numbers. But we have to recognize them because they're going to happen half the time. So we just can't avoid them anymore. We have to be like, we're going to face this and kind of move through it. But if you went back to your Algebra 1 class, you would see you never had an odd number. But so I just avoided them. We were focused on just the idea of completing the square, not the whole picture as a whole. So today we're going to kind of face them and just work through them. So let's look at our first one. First of all, we have something squared equals 16. The reason I can put it as something squared is you might notice that x squared plus 10x plus 25 is a perfect square trinomial, because what's half of 10? 5. And what's 5 squared? 25. So we don't need to move the 25 over just to add it back again. And so this problem, sometimes, on a very rare occasion, you might have a perfect square trinomial here. And if you do, you can jump right to that step, which is really nice. Now we're going to take the square root of both sides. So I'm going to take this, and I'm going to take that. I'm going to take the square root of the left and the square root of the right, and don't forget to put your plus or minus there. So now I have x plus 5 equals plus or minus 4. How many answers did we have? 2 square roots, so we have 2 answers. And so here's where we're going to have to break it up into our 2 parts. First part, x plus 5 equals negative 4. Second part, x plus 5 equals positive 4. Now I solve each one. X equals, let's see, subtracting 5, negative 9. X equals subtracting 5, negative 1. So I write my solution just like so. Very similar to what we did the other day, completing the square. 2 answers. It's a parabola, so we're in good shape there. All right, let's scroll over here to the other one. First of all, let's do some examining. What's half of negative 4? Negative 2 squared. So is this already a perfect square trinomial?
Yes.
Yes. So that's not going to happen that often. But Layla, when it does, take advantage of it. All right? So let's go right to x something squared. X what squared? Minus 2. So remember that minus sign travels right down. Equals 9. Let's take the square root of both sides. Don't forget your plus or minus. That gives me x minus 2 equals plus or minus 3. We're 90% done at this point. I break it up into my 2 parts. What's my first part on the left? Equals 3. My other part, x minus 2 equals negative 3. All right? So I get x equals 5, x equals negative 1. Do you agree? So negative 1, comma 5. Did I explain the order in our answers and why we put them in a certain order? Just numerical, whatever's on the number line, lowest one first, highest one second, that kind of thing. So any questions there? completing the square. When you recognize perfect square trinomial. Now, Lydia, I noticed on the first one you were jumping right to moving it over with the plus blanks. That's where we're going next. So each of our problems is going to build with a different little component as we move through. We're going to do whole numbers, rational numbers, complex numbers. So I'm trying to kind of give us each examples of each idea. So here it says real solutions. So that means we might have square roots, which is okay. So let's look at this first one. Here we go. First step. Take that 10 and do what? Move it over. Second step. Put in your plus blanks. What do you think is going to go in our blank? And here's 16. Do we agree why? Why 16?
8 divided by 2 squared.
Okay, 8 divided by 2 squared. Thank you, Trevor. So 16, balance it with another 16. So let's rewrite this. X plus 4 squared equals 26. Take the square root of both sides. When you take the square root of both sides, don't forget that plus or minus. So we have x plus 4 equals plus or minus the square root of 26. Let's do some estimating. In between what two numbers is the square root of 26?
25.
It's in between 5 and 6, right? Because in between 25 and 36. So it's 5 point something. I'm not looking for a decimal answer here. Not looking for a decimal answer. So what I am looking for is just a simple answer, which is -4 plus or minus the square root of 26. That is my answer. If you wanted to, you could write it like this. But most textbooks and most people will write the answer like so. Notice on each of the answers, it's still a -4. Sebastian, that make sense? All right, let's look over at our next one. Are we good here? Can I just slide over? All right, your turn. Walk me through. First step. Move the 2, okay? Leave a big blank, anticipating what you're going to do. Okay, we're going to have to do a little sidebar here. Half of -5 is what? -5/2. And -5/2 squared is 25/4. So 25/4. 25/4. What's being squared? I see a couple of people have x minus. X minus what?
5/2.
Yeah, x minus 5/2. X minus 5/2 equals, I've got to convert this 2 into fourths. So that's 8/4. So x minus 5/2 squared equals 33/4.
Where do you get the 8/4?
I converted the 2 into fourths, anticipating, Trevor, combining the 25 and the 2. And I have to have a common denominator.
How do you do that?
Well, I have to have my denominator being 4s. So 2 times 4 is 8. So I just made a common denominator in order to convert the 2 into 8/4. Now I'm going to take the square root of both sides. Remember, when you take the square root of both sides, you have a plus or minus. So now we keep going. X minus 5/2 equals plus or minus the square root of 33. And what's nice about the denominator? It becomes a what? 2. Because the square root of 4 is 2. So x equals 5/2 plus or minus the square root of 33 over 2. Now, or x equals 5 plus or minus the square root of 33 all over 2. Do you see how both the green and the blue answers are really the same thing? The book might write it blue, they might write it green. I need you to understand that there's nothing different between the two. Very similar. So don't feel like one is right, one is wrong, neither is awkward. Both you will see consistently. You just have to know they're the same. All right, so with real solutions, we've got some possibilities there. You might have a radical, might need to simplify. Okay? Questions so far? Am I going slow enough? All right, let's move down. Example 4. What's the title? Complex, which means what do you think we're going to be having as possible answers? I's. Okay, so here we go. X squared minus 2x plus blank equals -4 plus blank. Catherine, Una, or Madeline? What goes in the blanks?
Just one.
It is. It is just a 1. All right. So something squared equals -3. What squared? X minus 1. All right, let's take the square root of both sides. Square to the left, square to the right. Don't forget the plus or minus. That's key. So that leaves me with x minus 1 equals plus or minus. Someone help me here. This is straight from yesterday now. That's what we had to do yesterday's lesson first. Yeah, the square root of -1 times the square root of 3. Nice job, because you broke that up. And I'm anticipating, what are you going to do with that square root of -1? Turn it into a what? Turn it into an I. Good job, Layla. All right, well, let's finish it up. X equals 1 plus or minus I root 3. So now that we can deal with imaginary numbers, when you have a square root of a negative, it's no longer an issue. You just bring the I out and keep going. Good catch, Layla. I don't think this one really was that hard, was it? You just have to deal with the -1. That's it. All right, let's slide over. Sebastian and Moss, help me here. X squared plus 10x plus blank. -29 plus blank. Help me with my blanks.
25.
Sebastian, you agree?
Yeah.
Why? I like his answer.
10 square root.
Okay, half of 10. Half of 10 is 5, and so that's where we get this next line from. Equals -4. Oh, that's convenient. -4. What's nice about -4? It's a perfect square. All right, so let's take the square root of both sides. Oops, I'm going to do that in red so it stands out a little bit. Don't forget your plus or minus. So that leaves me with x plus 5 equals plus or minus. What happens to the negative? Becomes a I. And what's the square root of 4? 2. Now I know it's I2, we're not going to write it like that, so we're going to change that obviously to I. So x equals negative 5 plus or minus 2I. Yes, sir.
It's not about this one, the one before.
Uh-huh. Let me slide back.
When it was, okay. So you just leave it as, so after you get to the, root -3, that x minus 1 is equal or plus or minus, you just take out the -1 and like.
And the -1 becomes an I.
Okay.
The square root of -1 becomes an I. Over on this line, we did that in one step. That's all. You're going to get better. The negative inside a radical just comes out as an I. And you're just going to get to the point where we don't write -1 times the number. You're just going to bring it out. Boom. Okay? So that was with complex. All right, so now, here's our final piece. A number in front, right? Because wasn't that the final thing we did with our parabolas? We had a value of A. And so here's our final piece of value of A. So let's just deal with it. It's really simple. How do you get rid of an A? Divide by it, okay? So let's just put a little note here that just says divide by A.
I can learn to understand you much better if I can get familiar with the way you talk.
All right, so here we go. We divide by A. X squared minus 2x minus 7/3 equals 0. Would you agree we got rid of the 3? Pretty simple. Now let's just do the problem just like normal. All right, here we go. X squared minus 2x plus blank equals 7/3 plus blank. Madeline gave it to me before. Grace? Stephen? What goes in the blanks? 1. A 1. Grace, do you understand why? All right, so Trevor, I need to combine the 7/3 and the 1. So I'm going to rewrite the 1 in terms of thirds. So that's 3/3. Nothing fancy. So now I combine them. X minus 1 squared equals 10/3. And I've intentionally written that 10/3 a little bit to the right because I'm about to take what of both sides? The square root. Square root, and what goes in front of the square root? Plus or minus. That leaves me with x minus 1 equals plus or minus the square root of 10 over the square root of 3. And we did this yesterday, right? Am I going to leave that square root of 3 on the bottom? What am I going to multiply by? Yeah, another square root of 3. So, let's see. X minus 1 equals plus or minus the square root of 30 all over 3. How did that just become a 3? The square root of 9, right, Joey? All right, so let's finish. I guess I got to bring the 1 over. X equals 1 plus or minus the square root of 30, whoops, over 3. Or x equals 3 plus or minus the square root of 30 all over 3. On that second one in red, what I did, Joey, was I said, hey, if I want to bring that 1 into the fraction, I got to multiply it by 3. And so you're going to see possibly both answers. Once again, understand both are fine. Both are perfectly correct. Neither is right, neither is wrong. So we've got those two issues going on here when we've got dealing with the radical in the bottom and dividing by the A in the front. So those two issues were kind of familiar things. Layla?
Is it, just for like future reference, is it ever possible to set it equal to 0 or no? To solve it,
To set it equal to 0.
like to solve it to 0?
Uh-huh. Well, that's what we did originally at the beginning of the chapter with factoring.
Oh.
But I don't think this problem is going to factor. Factoring, you guys have to realize, happens about as often as a fast break in basketball. Pretty rarely, okay? But does it happen? So when you have an open fast break, you take it. When you can factor, you do so because it's quick. But don't waste too much time on factoring because there's a good chance it might not work. And if it doesn't work, you're going to have to set up your offense and run your offense. And this is our offense. It's a standard. This will always work. But factoring, if 1 and 10 and 2 and 5 don't work, then all of a sudden you're like, oh, okay, I better complete the square, use the quadratic formula. So, all right, let's look at our last one. I put this one on intentionally because what is the value of a? -1. So divide everything by -1. Divide by -1 and I get x squared plus 3x equals -2. I left an intentional space there. All right. I have an odd number and we're not going to avoid it, but I'm going to do a little sidebar as a reminder. Half of 3 is 3 halves. 3 halves squared is what? 9/4. So let's add 9/4 to both sides. All right, so here we go. X plus, remember, the next blank is half of the middle term. What's half of 3? 3 halves. And I want to make sure that we're understanding that that's the 3 halves. Notice, 9/4 does not go there. 3 halves goes there. It's half of the middle term. Over here, Trevor, we're back to getting a common denominator. I got to have 2 turn into fourths. So -8.
Is that 1/4?
It is. Positive. Oh, and it's even a positive. So we're not going to have a what here? We're not going to have an I. All right, so we take the square root. We take the square root, plus or minus. Well, this is going to work out nice. X plus 3 halves plus or minus. What's the square root of 1/4? What's the square root of 1? 1. What's the square root of 4? 2. Right? Square root of the top, square root of the bottom. So let's break this up into our 2 parts. X plus 3 halves equals 1/2. X plus 3 halves equals -1/2. 1/2 minus 3 halves is -2 halves, right? Which is -1. -1/2 minus 3 halves is -4 halves, which is -2. So my answer is -2, -1. All right, so now Layla, getting back to your question. Originally, you see how nice and neat this answer is down here, -2, -1? If we had brought the x squared and the 3x over to the right side and set it equal to 0, this might have factored. No, let me rephrase that. This would have factored. But you're thrown a little bit because of that negative. So, this might have factored if we had seen it, but we still can do it with completing the square. And completing the square is much harder than the factoring. But it always works. That's the benefit of it. It always works. Could you always walk home? You could. But sometimes we take a ride from mom, or drive our own car, whatever the case may be. So what we've got is let's kind of go back here and let's talk big picture. First of all, just basic filling in the blanks of our completing the square. Second, we talked about odd and even numbers. Remember, half of the odds squared. Then we talked about rational solutions, where they're just going to work out nice and neatly. Then we talked about radicals. And then finally, we jumped to imaginaries, and then numbers in front of the x squared term. So it's really I tried to show you all the different possibilities to set you up as much as I could for as much success as we could. Make sense? So what I did is I kind of tried to just pick out problems that keyed in on what we absolutely needed to know. And I just picked out a couple problems from each part to hopefully allow you to make that work.